Hey everyone, welcome back to another CIE A Level Maths past paper video. Today we're going to talk about paper 3, variant 3.1 from the May-June 2025 series. So let's jump into the paper. Sketch the graph of y equals to 2x minus 3. So obviously this is going to be a V-shaped graph because there's no plus minus factor over here. Furthermore, you can watch our revision playlist video on V3 modulus functions to understand and practice how to sketch these type of graphs. Basically what we're trying to do over here, when we express it in this way, it becomes a piecewise function. So you have one part which is 2x minus 3 and the other one is 3 minus 2x. To figure out which range each of these functions belong, we need to figure out where 2x minus 3 goes below 0. So when you simplify and solve this inequality, this becomes 3 over 2. That means it becomes negative when you are below 3 over 2. But greater than equal to 3 by 2, it's just going to remain 2x minus 3. So you have sort of like this graph. Yeah, that's it. And this is your 3 because this is your 3 minus 2x part. And this is your 2x minus 3 graph. And this is your 3 by 2. This is your y-axis. This is your x-axis. Right, that's it. That's your sketch. Solve the inequality 3x minus 1, 2x minus 3. Okay. Now, two ways to do this with algebra without the need for any graph. But since we have been asked to make the graph for 2x minus 3 mod, it's better to see from the graphical perspective also. And then I will show you how to figure this out using algebra. Now, 3x minus 1 would mean that this is, let's say, if this is 2, this is 1, minus 1 would be somewhere over here. And this is 3x minus 1, so this means that it will have a larger gradient than the other one. So somewhat like this, maybe like a little bit more steeper. But this is your 3x minus 1. Minus 1. So as you can see there, it's only this part that will intersect with it. 2x minus 3 will never intersect with it. So when you equate 3 minus 2x with 3x minus 1, you will get the right answer. But if you want to do this with just plain algebra, you could do this very specific way. So we cannot just simply use the squaring method over here. Why? Because in our revision videos also, I showed you something to look out for. If the gradient of the function, which is not bound by the modulus operator, has a gradient which is higher than this one, then obviously this means that only one part of them will intersect. So that way, for this case, we have to split them together, split them apart. So you will have a portion like solving this equation, and 3x minus 1 equals to 3 minus 2x separately. However, they're bound by different conditions. So 2x minus 3 is after 3 by 2, because obviously it's like we wrote it over here also, that this is applicable only for x greater than 3 by 2, and the other one would be less than. So I'm using the intersection symbol because we have to the solution that we get from either one of them has to be applicable to the range also. It should lie in that particular range. So 3x minus 2x is just x equals to minus 3 plus 1 minus 2. But when you see this thing greater than 1.5, so minus x equals to minus 2 and x greater than 3 over 2, obviously there are no solutions because minus 2 is not greater than. So no solution from this one. But from this one, if you see this, you have 3x, this would become 5x, and this becomes 3 plus 1, 4, and this becomes 4 over 5, and when you see, yes, it does indeed lie in that region. So therefore, x equals to 4 over 5. This is your critical point. This is your critical point. You could have done the same thing with this plain less than also. So for example, if I just do this with plain less than symbol, I will get exactly the same thing. So 3x minus 1 less than 3 minus 2x, x less than 3 by 2. You will get exactly the same thing, 5x less than 4 and x less than 4 over 5, 3 by 2. So this means that the solution is correct because 4 over 5 is less than 3 by 2. So therefore x less than 4 over 5. This is the final answer. Okay. Alright, so let's move on to the next question. Question number 2. It is given that 2 ln p plus ln p minus 1 minus 1 over 2 ln q plus 1 is equal to 3. Find q in terms of p. Okay, so what we can do, we can make this a little bit simple first. Simplify first, plus ln p minus 1 minus 1 over 2 ln q plus 1 equals to 3. To get rid of this 1 over 2, we can multiply both sides by 2. So we get 4 ln p plus 2 ln p minus 1 minus ln q plus 1 equals to 6. Take ln this on the other side, and this can become 6 ln e, right? So this would become ln q plus 1 equals to 4 ln p plus 2 ln p minus 1 minus 6 ln e. Now we take care of the powers. This becomes ln p raised to power 4 plus ln p minus 1 squared minus ln e raised to power 6. Okay. Now we compile them, lump them all together. So ln p raised to power 4 times by p minus 1 squared divided by e raised to power 6. So both sides are ln of a function, so therefore now we can equate the arguments. So equating arguments, you get q plus 1 equals to p raised to power 4, p minus 1 squared, e raised to power 6, and therefore q is going to be p raised to power 4, p minus 1 squared, e raised to power 6 minus 1. And that's it. Right, okay, now let's move on to next question. Question number 3. Find the complex numbers z for which z plus 5i over z minus 5 is real and mod of z, that means the magnitude of z, is square root 70. Give your answers in the form z is equal to x plus iy, where x and y are real. Okay, now there are two methods to solve this, and let's say how much space do we have? Right, okay, so we have 2 pages. Now I'll show you two methods for this. One, if you split z into x plus iy, that is perfectly fine, but that would become very long. However, there is an easier, not easier, it involves a little bit less, but almost the same amount of working. Now, z is a complex number, we know that, right? So when we add or subtract something into it, the other one will also be a complex number, right? We know that, for example, when we have z over z1, it's basically we are doing R1 over, sorry, the magnitude of that, sorry, Z1 over Z2 e raised to power the argument of, right, we don't need this over here, we need over here argument of Z1 minus argument of Z2, right? So sort of like this. This is in the exponential form. You could have the cos theta plus I sin theta form also, right? But either way, the argument of Z1 over Z2 is going to be always argument of Z1 minus argument of Z2, right? Now, if the Z1 over Z2, this thing is real, right? So that means the difference of their arguments will be 0. So either it's 0 or n pi. Okay, where n is basically an integer. Okay. Another way to understand like what we are actually saying is the argument of Z1 is coming from the, if we draw the Argand diagrams, for example, this is your Z1 and this is your Z2, for example. Actually, since we want them to be real, let's make it this way. So for example, let's say this way. So either the difference between them is 0, that means they are going like this way, both of them going this way, or they are going opposite way. Okay, or this could be repeated also. Now, when we figure this one out, so you have the argument of z plus 5i minus argument of z minus 5. This is equal to 0 or pi. Okay? Right? Now, when we since we have already determined that either they are in the same direction, so if it's 0, they are in the same direction. So if 0, then they are in same direction. Then same direction. Either way, this means that they are collinear, right? So this tells us that these two complex numbers are collinear. They are lying on the same line. So if this is the case, if we include z plus 5 would mean that you have x plus I y plus 5i. Actually, we can lump it all in one, right? And this one is x minus 5 and plus iy. Now they are lie on same line, right? So this means that we can apply the gradient formula, or we can say that they are on the same line. So if we apply the gradient formula, right, from 0, from the origin, either way, right, whether it's 0 or pi, so we're either getting let's say y plus 5 over x equals to y over x minus 5, right? So when you do this x minus 5 over x, you get y over y plus 5. Either way, whichever way you want to write this. If it's minus pi, if it's pi, the basic thing would remain the same, right? So it doesn't really matter over here, right? So actually, I drew this to continue the working. Now, let's cross multiply. Either way, you could have done the cross multiplication, we would have been the same. So xy equals to x minus 5, y plus 5. So you have xy equals to xy plus 5x minus 5y minus 25, and as you can see, xy gets cancelled. You have 5y equals to 5x minus 25. Divide 5 on both sides, you get y equals to x minus 5. Now this is the line on which the complex number z plus 5i and z minus 5 lie. Okay. Now we need to employ the other condition, mod z that. So mod z is equal to x squared plus y squared is equal to root 17. So this sum of squares is 17, right? So y is equal to x minus 5. So let's plug it in. So x squared plus x minus 5 whole squared equals to 17. So x squared plus x squared minus 10x minus 25 plus 25, and minus 17 equal to 0. This becomes 2x squared minus 10x plus 8 equal to 0, which can be further simplified to x squared minus 5x plus 4. Okay. Now this is easy to see because the product is 4 and the sum is negative 5, so it's x minus 1, x minus 4. So this is equal to 0, so either x is equal to 1 or x is equal to 4. That means y is equal to x minus 5, so y would be 1 minus 5 minus 4, and y is 4 minus 5 minus 1. So the coordinates are therefore 1 minus 4 and 4 minus 1. Now this was the geometric way of doing this. How would we have done this algebraically? So let's do this. So over here we would have to split z as x plus iy. So strictly like using algebra, simply just using x plus iy. So you have z plus 5i over z minus 5, right? That's it, right? Yeah, okay, alright. So this would split into x plus iy plus 5i. This becomes y plus 5i divided by x minus 5 plus iy. Now we need to rationalize this. So this would become x minus 5 minus iy divided by x minus 5 minus iy. So when we do the multiplication now, so you have x times by x minus 5 minus xy, just to place it somewhere else, and then you have x minus 5 y plus 5 I, and then you see I squared is equal to negative 1 already. So this times by this would actually be positive y times by y plus 5, okay, divided by x minus 5 squared. Normally it would have been minus I squared y squared. This would become plus because of the same thing. Okay, so now let's expand this all. Actually, let's start from over here. Right, so this is x squared minus 5x minus xyi and xy plus 5x minus 5y minus 25. Sorry, this was all in I, right? So this is your I, this is your I, this is your I, this is your I, and this becomes y squared plus 5y, right? Okay, the denominator will stay as it is, plus y squared. Okay, so let's see if we can simplify a little bit. Okay, right, now let's separate the imaginary from the real. So you have x squared minus 5x. So the imaginary components are these, right? So this plus y squared plus 5y divided by this x minus 5 whole squared plus y squared plus this is actually I think we could have just kept it this way also, x minus 5 y plus 5 I minus x y I divided by x minus 5 squared plus y squared. Okay, the imaginary part is 0 since quotient of these two complex numbers is real, therefore this particular part would be 0. So therefore this means that the x minus 5 y plus 5 minus xy is 0, right? We don't even need to worry about the denominator. Okay, so let's expand this again. So we had xy over here plus 5x. This is not minus, minus 5y minus 25 minus xy equal to 0. You get xy 0. You see we are getting the same equation as before. So you get 5y equals to 5x minus 25, which can be written as y equals to x minus 5. And then the other process is the same. We have mod z is equal to x squared plus y squared equals to 17, and then we would apply this thing right over here, and then we would get the same process. Okay, right, just to finish this, we can do that. So 17 is equal to x squared plus x minus 5 whole squared equals to 17. So as you can see, this is exactly the same working that we had right over here. So this process is identical, so we don't need to repeat it. Now, even though we have got the 2 points over here, this was not the final answer. The final answer, remember, we have to write it in the form z is equal to x plus iy. So we have these. We need to write the final answers as z is either 1 minus 4i or z is equal to 4 minus I. This is our final answer. Okay. Right, that's it. Let's move on to the next question. The parametric equations of a curve are x is equal to e raised to power tan t, y is equal to 3 tan squared t. Find the equation of the tangent to the curve at point E3. Give your answers in the form y is equal to mx plus c, where m and c are exact. Alright, so the first thing we need is to figure out the value of t that corresponds to this. So x equals to e exponential tan of t, and this is equal to e, right? So e exponential power 1 equals to exponential tan of t. The answer is obviously tan t equals to 1, and we're going to get pi by 4. The other one, you have 3 3 equals to 3 tan squared t. We can cancel out 3 and 3. However, this would mean that tan of t is plus or minus 1 when you take the square root. So we are only looking for positive 1, right? So therefore tan t equals to 1 corresponds to t is equal to pi by 4. Now we need the dx over dt and dy by dt. So the derivative of tan t is secant squared t times by e raised to power tan t, and then dy by dt is the derivative of tan squared, so 3 times by 2 tan of t times by the derivative of tan, which is secant squared t. Right? Okay. Now before we do the chain rule over here, it would be wise to just simply plug in t is equal to pi by 4 right into at this moment. So first off, we can just simply figure out what secant squared pi by 4 means. So we can do this without the help of the calculator also. Secant is based on cos. So cos of pi by 4 is under root 2 over 2. Or you can say 1 over root 2. So 1 over cos of pi by 4 would mean that this is just root 2. And if this is secant, so this is your secant pi by 4. So if this is secant squared pi by 4, this is going to be just 2, right? And tan of t is already 1. Okay, so you just have 2 times by e raised to power 1, and this is equal to 3 times by 2 times by 1 times by 2. So this is your 2e and this is your 12. Okay, so dy by dx, the gradient, is dy over dt times by dt over dx. This would become 12 over 2e, so this is 6 over e. Right, okay, now we need this is your gradient, m, gradient. Okay, so now we apply y equals to mx plus c, or y minus y1, equation of tangent y minus y1 m. So y minus 3, gradient is 6 over e, right? So you have ey, actually no, sorry, we can keep it like this because we need it in the form y is equal to mx plus c, right? Yeah, right, okay. So you have 6 over ex minus 6 over e times by e is just 6 plus 3, 9. Sorry, plus 3. This is 6 minus 6 plus 3, this is minus 3, sorry. Right, and right, that's it for this question. Let's move on to the next one. Okay, so question number 5. The polynomial is denoted by f of x, where p, q, and a are constant, and a is not equal to 0. When f of x is divided by x plus 2a, the remainder is minus 22a cubed, and when it is divided by 3x minus a, the remainder is minus a cubed. Okay, alright. Find the values of p and q. So we have two unknowns, two conditions to solve them. So let's start with this one. this would mean that this is minus 2a, right? So minus 2a. So 3 minus 2a cubed plus pa minus 2a squared plus 7a squared minus 2a plus qa cubed. Okay, let's simplify this. Minus 2 cubed is just minus 8. Minus 8 times by 3 minus 24. A cubed. And 4a squared, this would be 4a cubed p plus 14 a cubed plus q a cubed, and this is equal to minus 22 a cubed. This means that when you cancel out the a's on all sides, you get 4p plus q equals to minus 22 plus 24 plus 14. Right? So minus 22 plus 24 plus 14 is 16. Okay, so this is our first equation. Right, the next one is 3x minus 8. So that means f of a over 3. Okay, so you have 3 a over 3 cubed plus p a over 3 squared plus 7a squared a over 3 plus q a cubed. This is equal to minus a cubed. Right, so 1 over 3 cubed is 1 over 27, so 3 divided by 27 is 1 over 9 plus 1 over 9 p a cubed plus 7 over 3 a cubed plus q a cubed is equal to minus a cubed. Once again, we need to cancel out the a cubed because this is a common factor in both sides. So you get 1 over 9 plus 1 over 9 first, okay? 1 over 9 p plus q is equal to minus 1 over 9 minus 7 over 3. Right? So we have minus 1 divided by 9 minus 7 divided by 3, which is minus 31 over 9. Okay? So minus 31 over 9. So when we multiply both sides by 9, you get p plus 9q equals to minus 31. Right. Now this is the second equation. So you have 4p plus q equals to I think we can substitute that, right? So q is equal to 16 minus 4p. So in the second equation, p plus 9 16 minus 4p equals to minus 31. So p plus in 9 times by 16, 144 minus 36p equals to minus 31. So minus 35p and 144 plus 31 is 175. Negative. Minus 31 minus 144. And 175 divided by 35 is 5. So P is 5. Therefore Q is 16 minus 4 times by 5. So 16 minus 20 is minus 4. Right. So that's basically it. Right. Alright, so that's it for this question. Let's move on to the next one. Question number 6. It is given that z1 is equal to 3 e raised to power 1 over 4 pi I, z2 is this, omega is this. That means omega is also another complex number. State the values of omega z1 and omega z2. Give your answers in the form r e raised to power I theta. Right. Okay. So whenever we are multiplying, whenever we are multiplying two complex numbers, their magnitude of the product is the product of the magnitudes, right? And the argument of the product is the sum of the arguments of individual complex numbers. So that's what we just simply need to do. So omega z1 is 2 times by 3 times by e raised to power a half pi plus pi by 4. Right, so this would become 6 e raised to power 3 by 4. Right, 3 by 4 pi. Sorry, 3 pi by 4 I. Now omega z2 on the other hand would follow the same process, 2 times by 3 by 2, which is just going to be written like this, an exponent half pi plus 1 over 6 pi I, sorry, there was an I over here also, I. So 1 divided by 2 plus 1 divided by 6, sorry, 2 by 3. So this is 3 e raised to power 2 pi by 3 I. Okay. On a sketch of an Argand diagram with the origin O, show that the points A, B, and C, D representing the complex numbers Z1, Z2, and okay, alright. So right, okay. So Z, we have to keep the magnitudes a little bit relevant, or sorry, understandable. So Z1 is 3. We need to go to 6 for that, for WZ1, omega Z1, sorry. Then you have 3 by 2 and this. Okay, so pi by 4 is 45, 3 pi by 4. So let's say like this. This is our Z1. Then Z2 is 3 by 2, 1 over 6 pi I. This is 3 by 2 magnitude or length, and the argument is 30 degrees. So roughly somewhat like this, but half of this, roughly, right? So this is, let's say, Z2. When we multiply with omega, we get 6, 3 pi by 4. Now 3 pi by 4 is, we can just simply calculate 3 times by 180 divided by 4. This is 135. So 135 is right over here and double the length. This. So omega z1 and you have omega z2 2 pi by 3. So again 2 times by 180 divided by 3, this is 120. So 120 is a slightly, again half the length of this one, like this. So somewhat like this, somewhat like this, right? So this is your omega z2, right? So this is your A, this is your B, this is your C, and this is our D. This is your imaginary axis. This is our real axis. This is our origin. Now furthermore, what we can do is we can write their magnitudes and angles. So the first one is, z1 was 3 and pi by 4. So 3 and pi by 4. This one is pi by 6 and 1.5. Okay. And you see, like we can do the 2 pi by 3 over here also. Angle, this is 3, this is 6. And the angle for this is 3 pi by 4. Right? Okay. State the geometric effects of multiplying z and z2 by omega. So we have to see by deduction over here what is happening with this. So when we take z, as you can see, the magnitude of r1 is half the magnitude of that. So this is basically the omega z1 is actually multiplying r1 to get this, right? 2 times by magnitude of this is equal to the magnitude of omega z1. Okay? Similarly, the magnitude of z2 by that also is doing the same thing. So 2 times by R2 is actually doing the omega z2 magnitude. So this is the effect on magnitudes. But how is it changing or affecting the argument, right? So the arguments, remember, they are multiplied. So you see we had half pi is added when done, right? So half pi is added. This means that this is a rotation. Right, so basically argument of omega is added plus half pi. So basically this is in this direction. So rotation by pi by 2 radians. So that's all we have to write. So enlargement or scaling by a factor of 2 and rotation anticlockwise by half pi radians. Alright, so let's move on to the next question. Alright, so question number 7. express 5 sine x plus pi over 6 minus 4 cos x in the form this. Now notice that we first have to expand this one. Otherwise we cannot combine them both. So when we expand this, we get 5 sine x cos of pi by 6 plus 5 cos of x sine of pi by 6. Now sine pi by 6 is half, and cos of pi by 6 is under root 3 over 2. Under root 3 over 2. Okay, alright, so when we do this, we have 5 root 3 over 2 sine of x plus 5 over 2 cos of x. Okay, now when we add the minus 4x into that, so 5 sine x plus 1 over 6 pi minus 4 cos of x, this becomes 5 over 2 root 3 sine of x plus 5 over 2 cos of x minus 4 cos of x. This becomes 5 over 2 root 3 sine of x, and 5 over 2 minus 4 is minus 3 by 2. Yeah, minus 3 by 2 cos of x. Now, this is what we need to expand into this, right? So when you have 5 over 2 root 3 sine of x minus 3 by 2 cos of x, this is identical to r sine of x cos of alpha minus r cos of x sine of alpha. So r is just simply the sum of squares and square root of that. So 5 over 2 root 3 squared plus 3 by 2 squared. So 25 over 4 times by 9, 75 over 4 basically, right? So 25 times by 3, this is 75 over 4 plus 9 over 4, so this is 84 over 4, so basically r is square root of 84 divided by 4, this is root 21. Now, to figure out how to figure out the tan ratio over here, right? So the sine x component is the r cos alpha, 5 over 2 root 3, and the r cos x is r sine alpha, 3 by 2. So therefore your tan alpha is 3 by 2 over 5 over 2 root 3. So basically the root 3, the divide by 2 gets cancelled. So it's just 3 over 5 root 3 or under root 3 over 5. So the alpha therefore would be, we need it in radians. Yeah, okay. So tan inverse of square root 3 divided by, since we already have it, like we can make it like 25. So this is 0.3334. Actually 5. Okay. Radians. So right. So correct to 3 decimal places. So 333. Okay. So when we express it as root 21 sine x minus 0.333. Right. Okay. Hence solve the equation equals to root 7. Right. So we expanded this to wait a second. Right. So x has now become 2 theta. So root 21 root 21 times by sine 2 theta plus pi by 6. Oh, sorry, no, why am I doing this? Minus 0.333 equals to root 7. Okay, so this would mean that the sine of 2 theta minus 0.333 is equal to 7 over 21 root. So this is 1 over root 3. Okay, 7 over 21 is 1 over 3, so square root of that is 1 over square root 3. Right, so now we need to do the sine inverse. So just to make sure that we have the range correct. So 0 to theta to pi, when you multiply by 2, this becomes 0 to 2 theta less than 2 pi at minus 0.333. This is, 2 pi minus 0.333. This is 5.950. Oh, sorry. Right, just to have an estimate of the range that how much we're supposed to look for. So sine, so 2 theta minus 0.333. This is radians. So no need for this. Right, so we can do this with a cost diagram or with the help of the graph. So cost diagram, you see this is positive, so we will get 2 possible answers. And we need to go up to 5.95, so a little less than 2 pi, right? So we don't need to go there because this thing is positive, so this is just in first and the second quadrant. In the graph also we just need the first 2. So when we do the sine inverse of square root of 1 over 1 divided by 3, you get 0.6155. Since we need up till 3 significant figure, 3 decimal places, it's better to write the intermediate answers to more decimal places. So for example, you could do 4.8 also, right? And the other one is pi minus that, right? So pi minus that. So pi minus 0.61548. So pi minus that is 0.61548, a 2.5261. Okay. Now one by one we need to add the 0.333 and then divide by 2. So theta is equal to this plus 0.333. Actually, you could do the actual value also, the exact value which actually came from this, tan inverse of root 3 over 5. So absolutely fine if you want to choose that. So let's say, for example, if we choose to go over that way, this would look like tan inverse of square root 3 divided by 25. And this divided by 2 is 1.42930. And if we decide that we don't want this, right, the first one sine inverse of square root of 1 over 3 plus sine inverse of square root of 3 over 25, and we divide this by 2, we get 0.4846. 6. The other one was 4, 3. Actually, I did not say that. Okay, never mind. We need to up till 2 decimal places, so 0.48 and 1.43. Question number 8. With respect to the origin O and the points A and B have position vectors, these. The line L1 passes through points A and B. Find the vector equation for the line L1. Right, so we need the difference between them, like the direction vector, right? So, AB. So this would be OA minus OB, or OB minus OA, whichever way. This is your OA, and this is your B. So OB minus OA. So OB is 5I plus J plus 6K minus 2I minus 4K. So you get 3I plus J plus 2K, right? This is your AB, this is the direction vector. So the vector equation for L1 is R is equal to OA plus lambda AB. So OA is 2I plus 4K plus lambda equal times by 3I plus J plus 2K, and that is your position vector for line L1. Okay, the line L2 has equation this. Show that L1 and L2 do not intersect. Okay, so first off we need the parametric equation of the points of intersection. So when we equate the lines, okay, so we get 2I plus lambda 3I, 2 plus lambda 3. So basically what we're trying to do over here is in the parametric form, this is 2 plus 3 lambda, lambda j, or just simply lambda, and this is 4 plus 2 lambda, right? And this is equal to 2 plus mu I, then 1 plus 2 mu, and 5 plus 3 mu. Right, so basically the parametric form. So that's what we need. So 2 plus 3 lambda equals to 2 plus mu, and lambda equals to 1 plus 2 mu. So when we plug in lambda over here, so this would become 2 plus 3 times by 1 plus lambda, so 3 plus 6 mu equals to 2 plus mu. So 6 minus mu is 5 mu, 2 gets cancelled, so this is minus 3. So mu is minus 3 by 5, and that would make lambda to be 1 plus 2 mu, so 1 minus 6 over 5, so minus 1 over 5, right? So if we apply this onto, wait, how did I, oh yeah, right, okay, now we apply this to the third one. 4 plus 2 lambda equals to 5 plus 3 mu. Lambda is minus 1 over 5. and 5 plus 3 minus 3 over 5. So we just want to check whether both sides are equal or not. So 4 minus 2 over 5. This is 18 over 5. And this is 5 minus 9 divided by 5. This is 16 over 5. So obviously not equal. So therefore lines L1 and L2 do not intersect. Okay. Find the acute angle between the directions L1 and L2. So basically we just need the direction vectors for that. So I plus 2j plus 3k. And the other one was 3i plus j plus 2k. Right. So we need the dot product between them, right? And these 9 plus 1 plus 4, this is 14, times by 1 plus 4 plus 9, 14 also. So this is just the 14 cos of theta, right? So 3 times by 1, 3, 1 times by 2, 2, 2 times by 3, 6, equals to 14 cos of theta. So 5 plus 6 is 11. So 11 over 14. So therefore cos inverse. And do we need this in, yeah, so we can give this in degrees. 11 divided by 14 is 38. So this is 38.2 degrees. Okay. Right, so that's it. Let's move on to the next question. Question number 9. The constant a is such that the integral of 6x ln x dx is equal to 4 from 1 to a. Right, so this is the integration by parts, because 6x and ln x, they are not derivatives of each other. So u is ln x, because remember the rule I late or liete. So logarithmic are preferred to the algebraic ones for the selection of u. So this means that u prime, the derivative of u is 1 over x. V is 6x, and integral of v dx is 6x squared over 2, which is just 3x squared. Okay, now when we take the integral, 6x ln x dx from 1 to a, first off we need to apply the u integral v dx. So 3x squared ln x minus integral of 1 over x times by 3 over x. So basically just 3x. Right, so 3x dx from 1 to a. First let's simplify this first. 3x squared ln x minus 3x squared over 2 from 1 to a. Now we can plug in the values. Um, 3a squared ln a minus 3 over 2 a squared. ln 1 is 0, so this is just becomes 0 minus 3 over 2. This becomes, and okay, wait, wait. So 3a squared minus 3 over 2a squared is just 3 over 2 squared. However, it's not just, we can take 3a squared out. So this is your ln a minus 1 over 2 plus 3 over 2. And this is equal to, they gave us 4. Okay. In what form do we need it? Okay. Right, so we take 3 by 2 on the other side, so therefore you have 3a squared and then a minus 1 over 2. So since we need it in terms of a, no wait. Okay, this is I think the numerical solution problem. So 4 minus 3 over 2 is just 1 over 2. No. 4 minus 1 over 2, oh sorry, 3 by 2, 5 over 2. 2.5, right? So 4 minus 1.5 is 5 over 2, right? Then we take 3 on the other side, so this would be just times by 3, so 5 over 6. A squared comes on this side, so this becomes 5 over 6 a squared. Okay, so 1 over 2 goes on the other side, so ln a equals to 5 over 6 a squared plus 1 over 2. And this can be simplified into 1 over 6 5 over a squared plus, see this is 1 over 2, so 1 over 2, so 1 over 6 times by what is 1 over 2, is just this. Now we take the ln, e raised to power on both sides, so this would be a equals to this 1 over 6 5 over a squared plus 3, and that's what we needed. Verify by calculation that a lies between 2 and 2.1. So for example, if we denote a function of a to be a minus e exponent 1 over 6 5 over a squared plus 3. So okay, let's do that. So f of 2, so first we say 2 in the answer, then we do answer minus e raised to power a 1 over 6 5 over answer squared plus 3. Okay, so the first one is minus 0.0306 and f of 2.1. Okay, so if we do 2.1 and repeat the same process, right? So we get 0.1083. Sign changes between 2 and 2.1. Therefore, a lies between 2 and 2.1. Okay. Use an iterative formula based on an equation in part A to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, so we have iterative formula like this. We had exponent 1 over 6 5 over a n squared plus 3. So let's start with 2 or 2.1, either way that's fine. So a 2 would be, let's start with 2. So first let's save 2 in the calculator, then minus, e raised to power 1 over 6 times by 5 over a squared, answer squared, and then plus 3 brackets. So this is 2.030, and we needed 4 decimal places each, so 306. Then we continue to 2.0179, so 180, let's say. Then this is 2.0231, 2.0210, and I think it is up to 2 decimal places. This is becoming a constant, right? So 2.0219, right? So therefore, as you can see, to 2 decimal places, this is becoming constant. Hence, A is 2.02. Alright, so let's move on to the next question. Question number 10. Find the quotient and the remainder when x cubed plus 5x squared minus 2x is divided by this. Right. So we have x cubed plus 5x squared minus 2x minus 15 and divided by x squared minus 3. So times by x, this would get us x cubed minus 3x, like this. So minus plus, this cancels out, and we get 5x squared plus x, right? So, right, so plus 5, so you get 5x squared and minus 15, right, so we also have minus 15 over here. So minus plus, so you get x as the remainder. So remainder is x and quotient is x plus 5. Right, okay. The variables x and y satisfy the differential equation. It is given that y is equal to 2 when x is equal to 2. Right, you solve the differential equation to obtain an expression for y squared in terms of x. Okay, so first off we need to separate the variables. So 6y dy, and when this goes on the other side, now we can use the expanded form. So quotient first, x plus 5, plus remainder over x squared minus 3, right, dx. You can have 1 over 2 over here, right? Okay, now when we integrate this, you have 6y squared over 2 equals to x squared over 2 plus 5x plus 1 over 2. See, the derivative of the bottom expression, denominator, is on the numerator, so this is ln x squared minus 3 plus c, constant of integration. It is given that y is equal to 2 when x is equal to 2. So 6, 4 over 2, 4 over 2 plus 5 times by 2, 10 plus half, and then 4 minus 3, this is 1, so this would turn out to be 0. So 12 minus 2 minus 10. This is c, which is going to be c equals to 0. So y squared is c, the 3 will go on the other side. So therefore y squared would be 1 over 3. You have 1 over 2x squared plus 5x plus half, and then x squared minus 3. And you can multiply the 3 inside, so you have 1 over 6 x squared plus 5 over 3x plus 1 over 6, and then x squared minus 3 y squared. Okay. Alright, so let's move on to the next question. Question number 11. The diagram shows the curve y equals to cosine of x times y square root of sine 2x for 0 to x to pi by 2. Curve has a maximum point at M where x is equal to a. Find the exact value of a. So first off, we need the dy by dx. So you have u as cos of x because it's a product. V is the square root of sine 2x. U prime is minus sine of x, but v prime on the other hand is 1 over 2 sine 2x minus 1 over 2 times by the derivative of sine 2x, that is 2 cos 2x. Right, so now for the dy by dx, you have uv prime. So cos of x times by cos of 2x times by sine 2x minus 1 over 2 minus sine of x times by sine of 2x 1 over 2. Now we need to figure out where this is equal to 0. At x is equal to a. So therefore, cos of x times by cos 2 of x times by sine 2 of x 1 over 2 negative equals to sine of x sine of 2x 1 over 2. Alright, now if we square both sides, okay, so if we square both sides, we'll get at the square roots. You will get cos squared x, times by cos squared 2x divided by sine 2x equals to sine squared x times by sine 2x, right? So if you cross multiply sine 2x with sine 2x, it becomes sine squared 2x. So cos squared x times by cos squared 2x equals to sine squared x times by sine squared 2x. Okay. If we bring them all on one side, so cos squared x, cos squared 2x minus sine squared x times by sine squared 2x. So this is, notice, an identity, which is the compound angle identity, right? So this is, let me write over here. So this is basically, this is like cos A minus B identity. So cos A, sine A, cos B minus that. But this is in squared form, right? So cos squared minus sine squared, sine squared. So we need this in one expression, like one trigonometric ratio. And we know that this is equal to 0. Now, let's try a simpler way to handle this. So this appears to be difference of squares. So let's go cos of x, cos of 2x minus sine of x, sine of 2x times by cos of x, cos of 2x plus sine of x, sine of 2x equal to 0. So the easiest way forward, if you notice, let's make a small on this. Actually, we did not need that, but okay, never mind. So you see, this is the classic compound angle identity. So this is cos x plus 2x, and this is cos x minus 2x or 2x minus x, either way, because cos is an even function. So basically, you see, the product of these two is equal to 0. So basically, either it's cos 3x or cos of x equal to 0. So cos of x gives us pi by 2, and cos of 3x equals to 0 gives us right. So like 3x would still be what am I doing? Equal to 0. So 3x would be equal to pi by 2, and then x would be pi by 6. Now, since m is less than pi by 2, so m is at x is equal to pi by 6. Exact value there, right? So m x is equal to pi by 6. Right, okay. The region enclosed between the x-axis and the curve is rotated through 2 pi radians about the x-axis. Find the exact volume of the solid generated. So volume formula, we remembered, it's pi y squared dx. Okay, so the y that we have is this. Y squared would be cos squared x sine 2x. Okay, you have pi cos squared x sine 2x dx. Right? Okay. Now, we cannot deal with the powers of x in integration like this. We have to use the double angle identities of cosine. So cos squared, if you recall this, you have 2 cos squared theta minus 1. So cos squared is basically cos, let's write over here, pi. This is going to be 1 over 2 cos 2x plus 1 times by sine 2x dx. Right? Okay. Integral. So when we multiply this inside, so you have pi, and sorry, we also need it from 0 to pi by 2, right? 0 to pi by 2. So you have 1 over 2 cos 2x sine 2x plus 1 over 2 sine of 2x, right? Dx. Okay. Now the beauty of this thing is that cos 2x is the derivative of sine 2x. Especially if we multiply by 2 and this one more time. So if you need a little reminder what this is, so basically you have let's say u is equal to sine 2x, and u du over dx is your 2 cos 2x, right? So basically when you're integrating u and this, remember what this becomes, so du becomes 2 cos 2x dx. So basically you have u du as this thing, 2 cos 2x dx, right? So basically the integral would just be simply u squared over 2, right? Which is, in this case, sine 2x, my bad, right? Sine 2x squared over 2. There's a 1 over 2 already over here, so we'll multiply this by 4. So 1 over 4 sine squared 2x plus, now 1 over 2 is already multiplied, but the integral of sine 2x is minus cos 2x over 2. So minus 1 over 4 cos of 2x, and we need it from 0 to pi by 2. Okay, now let's do that. Pi 1 over 4 sine of 2 pi by 2, sine of 0 basically, minus 1 over 4 cos of 2 times by pi by 2. Cos of pi is minus 1, so this will become minus 1, right? And minus 1 over 4, again 0, minus 1 over 4 cos of 0 is just 1, positive 1. So let's simplify. 1 over 4 times by 0 is 0 plus 1 over 4 minus 0 and plus 1 over 4, right? Right, so 1 over 4 pi plus 1 over 4, or 1 over 4 plus 1 over 4 is 1 over 2, so it's basically 1 over 2 pi. Right, okay, and that's it for this paper. I hope you enjoyed solving this exam with me. If you have any questions, doubts, or confusions, feel free to reach out in the comments. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Furthermore, if you'd like to prepare for May June 2026 exams with me for pure math, statistics, or mechanics, also follow through on the links and the WhatsApp number given and join the May June 2026 sessions now. I also offer one-on-one, so that can be arranged also. Until the next video, take care. Bye-bye.